identifying all singular points and points of discontinuity of each of the given functions. These functions are piecewise functions. To determine the singular point or points of discontinuity, we first evaluate the function at the breakpoint and take the limit as well. For the first piece, there is only one breakpoint, that is at x equals 0. On the left-hand side of 0, the formula is x squared minus 1, and on the right-hand side of 0, the formula is x squared plus 1. We see that f of 0 is undefined. And since f of 0 is undefined because 0 is not included in the specified domain here, we say that x equals 0 is a singular point. A singular point is a point where the function is not defined. In this case, f of 0 is not defined. Since x equals 0 is not even in the domain, we do not need to check for its discontinuity. Each of the pieces is already in closed form, even though the function is not in the closed form. And so x squared minus 1 is continuous on its domain. X squared plus 1 is continuous on its domain. Therefore, the function f of x is continuous on its domain. We know if we were to check that this function is not continuous at x equals 0, but we do not need to state it because x equals 0 is not even in the domain. In summary, we say that x has a singular point at x equals 0, and the points of discontinuity is D and E, does not exist. Similarly, for part B, we will still need to evaluate the function at the breakpoint. But before we do that, for piecewise function, always write the formula for each of the specified domain. When x equals 5, the output is -3. That is what the second piece is telling us. And then everywhere else, the formula that we will use is 4 over x minus 5 squared. On the right hand side of 5, it is still 4 over x minus 5 squared. G of 5, by the definition, it is -3. And it is -3. The function is -3 only at x equals 5. Since the function is defined everywhere on this number line, there is no singular point. We still need to check for the point of discontinuity because there are two pieces in this non-closed form function. And so this is not done deal yet. We still need to determine the limit at x go to 5. At x go to 5, the formula that we will use is 4 over x minus 5, the quantity squared, both from the left and the right of 5. Remember that when x goes to 5, this x is not exactly 5, but it is almost 5. What this means is that on the left hand side of 5, x is approaching 5 by using 4.999999, for example. And on the right hand side of 5, a number that is almost 5 is perhaps 5.00001 and so on. If we take any of these numbers and we plugged it into the denominator, we see that x minus 5 is a very small number, and 4 over a very small number squared is still a very small number, and it is positive, and so this is going to be a very large number because a finite number over a very small positive number is a very large number. But again, infinity is not a number, and so this limit does not exist. Since the limit does not exist, we say that the function g has a discontinuity at x equals 5, and this is not a singular point. For this second part, the point of discontinuity is at x equals 5, and the singular point is D and E.